Hello, and welcome to the MIT SDM Systems Thinking webinar series. My name is Naomi Gutierrez, Communications Administrator for SDM, and I am today's host. Thank you for taking the time to join us today. We hope that this webinar can be a chance to recharge and learn something new. Today's speaker is Douglas Haig, Executive Director of the School of Data Science at the University of North Carolina, Charlotte. He has more than 20 years of experience as an executive advisor to leaders in healthcare, manufacturing, financial services, and the service industry. In 2018, he was named by Corinium Global Intelligence as one of the top 50 data and analytics professionals in the United States and Canada. Doug is an alumnus of the System Design and Management program and holds a PhD in Materials Science and Engineering and a master's degree in Metals Science and Engineering from Pennsylvania State University. His talk today is titled Beyond Bias: What Happens After We Know and Disclose the Biases in Our AI Models. If you have questions for the presenter, please enter them into the chat window at the side of the video on the YouTube screen. They will be addressed during the Q&A portion of this session. Finally, the recording of this presentation will be available online after today's session, and a link will be sent to all registrants. With that, thank you, Doug. Please take it away.
Thank you all. I appreciate the time today, and thank you, Naomi, for setting this up. I appreciate it. I am disappointed I'm not in Boston, but the COVID-19 virus has kept us all at home, and thank you to Zoom for having virtual backgrounds so you don't see my office. With that, I will go ahead and get started and share my screen here. This one. And let's get going. So as Naomi said, I have a system design and management background. I was actually the third class, so we called ourselves SDM 99. And I miss, again, seeing the current students and everything up in Boston. But I did work for Pratt & Whitney, Sprint, Bank of America, and the last position in corporate was Chief Analytics Officer at Bank of America Merchant Services. And then I came to academia at University of North Carolina, Charlotte, where we have founded in January the School of Data Science. So with that, it's very exciting, and I'll just get going. So thank you. So bias and fairness in AI. It's one of the hottest topics that exists today in the field of data science and artificial intelligence. This is not a new topic in bias. As in the 70s, the banks were actually, the Fair Lending Acts were credit approvals. The world about bias of who you were providing mortgages to was called redlining. That continues. Unfortunately, some of that continues today. If you Google fines on mortgages for banks, you will still find some of them being done today. And it's really transformed the industry on how we look at the fairness and the bias within our modeling and within the artificial intelligence. As modeling's evolved, obviously the techniques have gotten much more important to us. Also, some of the other things, it's not just financial services that have to worry about. Heart disease was historically always looked at with male patients. The American Heart Association has done a great job with their Women Go Red and looking at the research and building the data set to be able to say, here's what happens to women. They're very different. So still, as we get into the more recent news and what's really John that started this off, and I'd like to give credit to Joy Blumwini at MIT. Her master's thesis in the Media Lab really brought bias and fairness in the AI world to the general public. If you don't know Joy's work, she founded the Algorithmic Justice League. It's fantastic. It's really brought the yes. Okay, I can do that. Sorry. Zoom, screen share. That better? Sorry about that. I'm supposed to be an expert at this now. Okay. We will continue on. All right, apologize for that, and we will continue going. Where's my screen? Okay, interesting. After all the practice, this doesn't work. But anyway, Okay, there we go. So we'll continue going. Looks like I'm sharing now. But Joy's screen and Joy's work really brought this to the general public. And her recognition and her research was on the facial recognition and the gender and the skin color of people and how it really made a difference. Of course, there's other fields, criminal justice and recidivism, human resources, the resume screening. You know, Amazon and others found that as they were screening resumes, they tended to hire them as they had in the past, and that wasn't necessarily who they wanted with their diverse workforce. And of course, we talked about healthcare services and understanding that. And one thing I'll say is if you look at the COVID-19 research that's happening now and all the projections and work, what you're beginning to see is there's a difference. African Americans have a much higher rate of fatalities. At least that's some of the initial work that's coming out. We'll see. There wasn't a lot of data collected, but the bottom line is really understanding the bias in your models and how this is fair to the public and the people that are impacted by your models is just being amplified by artificial intelligence. So out of this presentation, I really want you to get two things. First is bias is not the same as fairness. Sometimes they're conflated with each other, but I'm going to talk about why they are not the same. The other thing, as you know, this is a presentation to the System Design and Management program. System thinking is really required when you're thinking about fairness. So if I can have you take those two things away, then I'll have succeeded today. But I'm going to back up a little bit and talk about some basic concepts and statistics that are important when you're thinking about bias and fairness within artificial intelligence and data science. So the first real concept is the confusion matrix. Some of you, if you're statisticians, I apologize. If you're not, maybe this will be helpful as part of the conversations. It's really understanding what you're predicting, which is your predicted case, and whether it's actual the case or not. So you have true positives. You predicted it to be true. It is true. True negatives. You predicted it not to be the case, and it in fact isn't. But then you have the false positives and false negatives. And as you're looking about this, and as you're looking at your particular situation, the cost of a true positive or a true negative is very different. And the mathematicians love this. You know, this is a very simplified case. It can get highly complex, but when you're actually measuring bias, you know, you can measure the accuracy, you can measure the sensitivity, which is just the true positive rate, the specificity, the precision, you know, all of these different measures of bias within a confusion matrix or measurement of a model. So what I'm going to talk about, though, is bias as a mathematical concept. As soon as you put it in a social system or a system, then bias has different viewpoints. If I'm one stakeholder, I may think that the true negative rate is really the important one. You know, who did you miss that was really the case? If you're in criminal justice, right? If you're the mother or the society out there, you do not want people that were predicted to commit crimes released. On the other case, if you're the criminal or the person that was accused, you want to make sure that you're not kept in jail and when you wouldn't have committed a crime anyway. So these true positive and true negative is really a mathematical function, but the bias is mathematical. But when you go into society, what I'm trying to convey here is bias is not the same as fairness. You really have to take the context and look at all the stakeholders to be able to do this and to analyze this very well. So fairness, you know, bias, many of us are mathematicians. You can actually calculate that. You can say I'm as unbiased as I possibly can. The other case, when you look at the context that your model and your AI is actually deployed into, then you have to start worrying about fairness, and it's really driven by the social construct. And by the way, social constructs are not the same around the world. Second concept that I would like to talk about is really what's called a ROC curve. Now, this isn't always appropriate, but in many cases, this is just true positives versus false positives. So as you're predicting, you have a probability of that's going to be true. And as you go down, the probability, you know, you'll start to bring in false positives. And you'll be in this area right here. As you go down in the probability, you're still picking up things that are actually true, but you also start picking up things that are not. So your true positive, false positive rate. For many cases where you have a sparse data set, you're going to pick a threshold of choosing what's true versus what's false in your prediction down in this area. Now, different ways, the more you push this way, obviously, the more true positives you get without having any false positives. So you want your ROC curve to be pushed into this corner. Unfortunately, when you're modeling, it's never perfect. So, but then as you go, you can see one model may be here, so this is not as good as a model. The other model may be here. But what the case I'm going to talk about now is really if this is your optimized model, your artificial intelligence on your prediction ratio, when you start to look at, and I'm going to bring a different concept in here, it's the ability to look at subgroups, often called protected variables. So what is your ethnicity? What is your race? What is your age? Different things depending upon your regulatory environment. But if you start to split into groups, so for example, your model is here, but if you choose people that are young, right, your model is not going to be very good. If you choose people that are old, maybe your model's a little better, or whatever the subcategory is, right? Unfortunately, it isn't always that simple. If you look, right, at different subcategories, different shapes of curves will come out. But really the case here, and what I'm trying to get and convey here is once you've built a model, when you're looking at the subcategories or the protected variables or whatever you look at when you're looking at bias, it is not going to be the same for each group. And in fact, there's some research that's been published that it's in practice, it's actually, you cannot make it. You cannot make your bias the same for all your subgroups. It's just mathematically impossible. If you have a perfect data set with perfect samples and they're all the same, then sure, or if you have two, you might be able to pick that point right there and have the same threshold, and your true positive, true false positive ratio would be the same. But in general cases, for all the models that are working in practice, you're not going to be able to perfectly match the biases in your subgroups. So you might have, 75% ratio in your older people that you're able to predict true positive versus false positive, but it might be 60% for a younger population. So again, right, bias is mathematically defined, and you can balance the bias, but actually balancing it perfectly isn't possible. But again, the other case is even if you balance it, fairness is not necessarily the same as bias. So, but now I'm just going to assume something. You've done this all, you guys are great. There is a lot of literature on how to remove bias from the modeling, and you've done it. Congratulations. I'm just going to make an assumption that you've done that. It's not easy. There's still a lot of new techniques being developed to be able to do this. But you've done, right? You've taken your input data and you've balanced it for your various subgroups. You've tuned the thresholds to make sure your ratios are appropriate. You've talked to people to make sure that the bias is appropriate. Maybe you even build separate models for different subgroups. There are many different techniques. I'm not going to get into those here. But I'll also say one of the oldest methods of doing this is just to remove the protected variables. So your race, your ethnicity, that's what we did in the financial industry. You removed it, your lawyers looked at it to make sure you weren't using any of the protected variables that you could get in trouble for. But what actually we found is your outcomes were still biased. So what's happening is you have correlations and other variables in your model that are correlated. Unfortunately, in the United States, income is correlated with ethnicity. So even if you're using any kind of income, which is very important in financial services and many models, right, you're going to be starting to distribute your race and ethnicity variables within that, and your income will pick that up. So that's very inadequate, but there are methods now to try and actually trace this and get around it. And I'm just going to say, you're done. You've done it. Congratulations. You've taken your model. You've made it as unbiased as you possibly can, and you're ready to deploy it. Okay, now the next thing, what do you do? So you're complete, you're done, let's go. However, you're actually starting to deploy this into a larger system. So let's talk about the system you're deploying it in. So you're collecting your data, you process it, you make your prediction, right? You've got your model statistics, your data is stable, the accuracy is what you wanted, all your key performance indicators are there, and your subcategory performance is as unbiased as you can possibly make it. Now you deploy it and you put it into a system, or maybe you project it to a human that then actually works on this and you have an outcome. So if you're measuring your bias here, which is number one, model prediction, and your stakeholders are measuring here, this interaction with the system and the human can actually rebias your model or come with a different outcome or a different expected outcome so that it's not fair in this case and at point number two, but at point number one, you've done everything you can and you've explained everything and it's as fair as possible. So you have to actually look at the larger system. Now there's some literature, being in the academic industry now, I look at all the literature and really it's all about how you define the system. And as SDM people, you've spent 2 years, a year, whatever you've been there in understanding how to define a system. So do you include the humans in the loop? Do you include the different systems that you're employing? Where are you measuring your accuracy of your system and your process versus the work in the actual model? You know, what cultural frameworks are you expecting? Are there users in different impacted group? And those are actually different. Sometimes the users of your model aren't the people that are actually impacted by the model decisions. You know, once you've decided and you've made it as unbiased as possible, should you actually be transparent about it? You know, you're deploying and talking and showing that your model isn't perfect. How will the public react? How will the stakeholders react? Do you have to manage regulators with this? And then, of course, what happens over time? Models, as they perform, right, they will typically degrade over time. So the framework that I like in this is actually by Selbst et al. On the framework for fair AI. I'm going to talk about a few of the things and then modify their framework a little bit. But we talked a little bit about framing, right? Where are you going to measure your system? Do you measure do you measure the model outcomes? Do you measure the system outcomes? Where do you do that, right? Oftentimes in industry, when we did this all the time, you're taking a model and you're applying it in a slightly different situation than it was developed in. So as you work through this, you know, the portability of your model is actually an efficient way to redeploy models. If you're in, you know, modeling medium businesses, so medium-sized businesses, maybe 100 million to 200 million sized businesses, and understanding how they react, can you take that model and apply it to a $50 million business? Maybe, maybe not, right? But you have to actually assume and look at that to understand it. Of course, we talked about the formalism, which is bias is not equal to fairness. And then I'm going to throw in an extra one, which is really trust. The privacy of the data, the transparency of your system. Are you building trust with the general public? And I would say Joy's work that I talked about before caused people to sit back and not trust AI as much as they had in the past. So as a group of developers, of practitioners within artificial intelligence and data science, we have to build the trust and show that we are actually doing the best we can with this. And then there's some trades that are very difficult, and depending upon the point of view of the stakeholder, it's a tough discussion. But let's go on and talk a little bit more about framing. So I'm going to give you a use case, and this is autonomous credit decisioning, right? So you have your credit bureaus, you bring in more data that you have inside your company, you're blending it all together, and you decide, you know, I'm going to offer you credit or not, right? And so you've measured that. I've said, okay, on all the outcomes, people take the credit, they don't take the credit. You know, is this fair? I've rebalanced my variables to make sure I'm not biased against one ethnic group versus another. And I'm saying, okay, my offer for credit is out there. So this is purely a fully autonomous system that you've deployed in. However, there's a human either accepting the offer or not, right? So then you have the outcome, right? I accepted the offer, I didn't accept the offer. I took the loan, I defaulted on it, I didn't default on it. All these decisions feed back in. Now, when you start to think about that, right, it was very efficient. I gave the offer in seconds, but somehow I just got fined for bias, right? Somebody went and did an analysis and I just got a $50 million fine because my mortgage applications were biased and I wasn't actually, people were not taking it. So what happened? Well, humans were involved, right? So even though it seemed like it was an autonomous credit decision, there were humans, right? You have to do what's called reject inference, which is a statistical a way of measuring those that didn't accept the offer. Would they have actually, did they get a loan somewhere else and did they default or not, right? And you have to realize there's a lot of differential information. You have a lot of information as the model developer, but your people that are deciding whether to accept an offer or not are not all on the same level of information, and different groups of people have different preferences and different amounts of information. And there's also, I'm assuming right now that you've made your debt offering into a culturally acceptable way of doing it. So liquidity offering, and are you doing different things and are you developing an asset? But even then, different cultures are willing or unwilling to take or like to use cash or debt. And so they have this bias one way or another within their own culture. So that will actually impact your outcome. And then finally, time is unstoppable. So if you had a credit offer that was out there today, right? Or out there, let's just say it was March 1st, and you had a credit offer out there and you were offering credit. And you continue to offer credit in the same model all the way till today. I will tell you, it is different. There are a lot more people accepting your offers of credit than there were in the past. Your model is probably not going to be as sufficient. You may have been using data that was 6 weeks old about their income. Their income is gone. So time is actually a very critical important in the concept of modeling, right? Economic conditions change. The COVID-19 is a very important or good example of this. I've been talking to other companies about looking at their models. What inventory of models do you have? Hopefully your company has an inventory of models. And if they don't, you better get one because you need to know which ones are broke and which ones are not, right? And then the other thing, even in normal times, individual and group behaviors, they migrate, they change. Fads come and fads go, but overall models tend to degrade over time. So there's a concept that I like to talk to people about, and it's really model risk management. It's where you're managing all your models in your company, and are they important, right? Which ones are the most risky? Which ones provide a lot of risk to your company? And which ones, if it doesn't happen and it can continue to run, but it really doesn't cost you a lot in the end, other than potentially running your model, that's okay. The financial crisis of 2008 really drove this practice into the financial institutions. One of the things I think we need to do, and I think COVID will do this, is understanding in other industries how model risk management really works and can bring benefit to the overall corporation about knowing where your models are, monitoring the behavior of them. I was in a company one time where we had deployed a model from 1997, and this happened to be 2015. So when we looked at the accuracy of the model, let's just say it wasn't as accurate as we had thought it was. So as you look at this and understanding the model risk management best practices that are coming out of the financial industry, applying those into your companies and your situations that you're in is an important aspect of this. I'll leave that for another day, but model risk management, there are some best practices that can say. Okay, so that's what is normally considered autonomous credit decisions. So let's change a little bit and let's go into what's now called human in the loop. Many of you have heard of, the AlphaGo, right? And chess playing with computers are actually better when you have humans making the ultimate decision. And so three humans and three chess. This is the story I've heard: 3 humans and 3 amateur chess players and 3 that are 3 different models that are building it can be, a master grand champion in chess. Why is that, right? So humans can actually improve the model capability by using their judgment. They can take into exogenous variables. They can look at the dynamics of the system that may be changing that you're not picking up in your model. And if you go back to the ROC curve concept, right, in general, where the computer is very, very positive that they're right, you should just let the computer make the decision. When the computer is pretty sure that you're wrong, you let the computer do this because you don't want to send this to humans because humans are a more expensive way to do this. But there's this group in the middle. An example of this is in the fraud world in financial institutions, right? There's some types of fraud that you can catch very easily and you just stop. There's some times where you get a phone call on your credit card that says, hey, is this you? Or a text message. They're trying to check to determine if it's really you or not. And so the human or someone in the background is looking at it and being able to do that. So what happens though when you bring humans back in? Well, as we talked about before, mental models in humans often include very powerful what's called information value in statistics. The information value of some of these variables is very powerful, but they're also a bias variable. So both the unconscious bias can creep back in because the mental models of humans are generally biased. So you have to be careful. And again, you want to measure before and after the human decisions. Even if you think it's a fully autonomous decision, right? You need to look and see where this is the case. Okay. So now let's move on to the next concept about portability. And it drives efficiency, but I would say it risks fairness, right? So as you're thinking about portability, right, you're taking the same model, same modeling technique, same capability and applying it in a slightly different area. You haven't necessarily gone through all the development. Maybe you didn't have all the data, so you're applying it to that situation. Generally, the adjacencies, right? So the areas just outside the data that you use during development, right? They're also areas that are outside of your assumptions, which sometimes your assumptions are implicit assumptions, sometimes they're specific. So understanding where you're deploying it and how the model was built, so you understand, do you think it's appropriate to deploy that in these adjacent areas, right? Sometimes people adopt models from the literature, right? Sometimes you apply it to a geographic area. I've built this model in the United States, or I've built it in North Carolina, right? And I think it's a great model, and now I'm going to apply it in Europe, right? And that may or may not actually work well. You can also cross client segments. So if I have one segment in my population, let's just say it's the millennials, and maybe is that millennial segment, can I apply it to the Gen Xers and actually try and understand how you're doing it. This is actually a fairly common practice within model development teams that are out in the world. But you've got to actually be very careful with this, because as you're going to the adjacent teams, now that you had tuned your model to be as fair as possible with the data you developed it on, when you move outside of those, there's different economic conditions, your behavior of those different, do Gen Xers and millennials actually behave the same? Sometimes they do, sometimes they don't. There's also different cultural norms. If you deploy in Europe or Asia or Africa, it's very different than if you're deploying in the United States, and you have different regulatory environments. So in some cases, some of the variables that are very powerful but are also protected in some countries, you can use those in others. Do you want to do that? Do you want to risk the fairness? And then of course, with COVID-19, there's a lot of models that are broken. So in emergency situations, there's a lot of people that are rushing, right? You're doing this as quick as possible. You're deploying your model, you're developing it, and you're looking at things. So let's just talk about the COVID-19 peak time, peak areas. It's continually improving as times to when that's going to peak with the number of infections or the number of deaths. But if you listen to the news, those models are moving every day. What's happening is there's better data coming in on the backside. But then, within the last week or 2 weeks, there's a lot of people starting to question the disparate impacts due to ethnicity, right? Some of the news I heard last night, whether I haven't confirmed this, so I don't know if this is true or not yet, but the disparity in the African American community, they're dying at much higher rates. Now, the doctors say, well, that's because they have a lot of conditions that cause it to be worse. Is that the case? Is it not the case? Time will tell, but in an emergency situation where we're making these decisions right now, right, you've got to make the decision. You've got to move on. You've got to consider and make this as fair as you possibly can. So is there any bias in these models or not? That will be determined, but we shall see. Okay. Moving on to the formalism piece, right? We talked a lot about this already. Social systems are people-focused, right? When you deploy into a society, there's of course many ways we've talked about measuring bias, which you know, different groups will have different rates, and if they're mathematically inclined, they may know they're choosing the different rates. But sometimes it's not even a mathematical argument; it's a political argument. It's an argument of passion or viewpoint that may not even be mathematical and can't be mapped to a particular mathematical bias. You have to take those views into account with the formalism, and you're going to have to try and balance them the best you can. And of course, as I stated before, it's mathematically intractable to actually balance it perfectly. So what do you do? How do you do those trade-offs? And if you're a corporation, right, you're trying to optimize your cash flow, your profitability, you know, you may say, hey, you know, that's a very small group. And we know it's biased against it, but we're just going to say, let's go ahead and deploy. There's actually a lot of case studies, and I'll bring this up. There's a list of references in the end that will make this available to you. There's some Princeton case studies on bias and fairness in AI situations. They're very good and makes you think about the decisions, but it's very hard to make these trade-offs when you have very different viewpoints. So if you've done this, now how do you actually make all these decisions? So now what? Okay. Well, one of the things is we have to generate trust, right? As a group, we've damaged the trust over the last few years for AI and data science, and we've got to work very hard to balance this, right? Part of that is transparency. You know, I've got on the bottom that the European Union's ethics guidelines for trustworthy AI. You know, so actually a very, very interesting document to read. They talk about transparency. They use the right of privacy. And it goes through many of these things. So it's a guideline for trustworthy AI. So it's a legalese or a regulatory document, but it is actually an interesting document to read. So you may want to take a look at that when you get a chance. But transparency. So you've got to trade off, you know, how much are you going to disclose to the public, right? And ensure some awareness that you're actually being truthful and explainable and are understanding the biases in your system, right? But you also need confidentiality, and you want your competitors to not be able to replicate everything you've done by being too transparent. So there's always a trade-off here. And then there's, of course, a lot of work about explainability. So explainability, especially in neural networks, you know, how do you tell someone why you made the decision? There's a concept in here in modeling of black box models versus white box models. The black box models, data goes in, an answer comes out, you don't really know why. Deep learning and AI, a lot of the neural networks have been that way in the past as black boxes, but there's a lot of work going on right now. It's very interesting about being able to explain why these neural networks are actually making the decision and being able to trace, here's where the data came from to be able to make this. So explainability and traceability is something that, you know, when people ask, if you're not necessarily going to disclose everything at the front, when people ask why did the decision get made, you know, this is one of those areas that you need to be able to focus on and do. Of course, privacy is a hot topic, right? Do people know you're actually using an artificial intelligence model? There's something in the EU guidelines or in the regulatory environment that's coming out that's called the right to be forgotten. So can you take your data out of the system? If you say, hey, I don't want my data to be used, can you as a modeler actually take your data out and retrain your models? And when do you need to do that, and how do you do that? These are not easy issues. You know, especially after you've anonymized a lot of the data, how do you take somebody's request to remove their data out of an anonymized data set? Those are the solutions, or those are the questions many people are asking now. Of course, there is ownership issues. Who owns the data, right? Do you own your healthcare data? Do you own your credit card data? Do you own any of the data, or do the companies that are processing the data own it? And what rights do they have? You know, PII, personally identifiable information, and protected personal information, PPI, are two of the concepts. And of course, the anonymization and re-engineering or unanonymizing things are the things that, you know, are those ethical or not? So a lot of different thinking through this. Of course, there's other things, human agency, robustness. I love the robustness talk, but I'm not going to go into that today, making your models robust to different conditions. But concepts and trust, you know, we really have to work on this overall as we are moving through to be able to say, you know, society can trust artificial intelligence, data science, the modeling that's being done, you know, because otherwise they'll reject the ability to use this and regulate, you know, and put regulations in place that make it difficult to actually use artificial intelligence. So we really need to work hard on this. And the trust and the transparency and privacy are all part of this. Okay, so let's think about the system again. You know, as you're optimizing fairness, you know, we talked about balancing the risks and the rewards, and each set of stakeholders is going to have a different view. So optimizing fairness, is that an oxymoron? It may not be possible to optimize fairness, but to be able to understand the fairness and understand the viewpoints that you're putting out, you know, you not only have to check the bias, which is mathematically, you know, you can define that. You can define it in many different ways. There was a time there that all the academics were going through and defining it in a new way and saying, hey, I've got a new way to define bias and fairness, and here's how you should do it. Here are the groups that would be looking at this way. But now we're really talking about fairness, and have you framed the system? So are you looking at the system and done your system thinking to be able to say, I'm not just looking at the modeling, but I'm looking at the system. And is the system fair? Not just the model fair, but is the system fair to our stakeholders and users? You know, and as you deploy, as you build in one area, you know, pilot or proof of concept in one area and then deploy in others, are you being culturally sensitive in this? And is it broad, and as that is broadly defined, you know, are the geographies is one of those things that you have to, is very common to deploy in new geographies and roll out in one state or one city, and then keep rolling it out further and further, and you're using the same models because you were successful. Is that okay? You should check. You know, the other thing is, as I talked about, model risk management. Are you monitoring this? And is it changing over time? It will change, I can tell you. And then the other thing is, are you discovering people that are deploying your models elsewhere that necessarily weren't thinking about this use case and as you were working in it today? And then, of course, the last, and this is one of the most difficult ones, is how much transparency is appropriate, right? Is it necessary, right? How are you doing this? Where do you actually disclose how that you have a model and how it works and how it may or may not have a little bit of bias left in it? Is it necessary to do it? Do you do it in a bunch of legalese like most of us click through? Or is there other ways where you're talking about it and working through this? Because transparency is key to being able to build a trust, have the general public trust our capabilities in artificial intelligence. Okay, so there are some interesting topics in fair AI that I did not talk about. You know, there is actually something called AI for social good. And a lot of times you're intentionally biasing your models. And the use case that I think about most often when I think about this is really the social determinants of health. So in the healthcare industry, if you're not familiar, there's something called the social determinants of health. You know, your doctor's decisions and recommendations, you know, are 40, 50, 60% of actually getting you healthy again. And then the system around you and your actual situation, your social situation, right? Do you live near a grocery store where you can get healthy food, right? What is your income level? How much can you afford to do? Can you get transportation to see a doctor? All these are called social determinants of health. They're also very, very ethnically, very age-driven. So they're using those variables for a social good. Now, in our society, that's actually acceptable. So they're intentionally biasing their models and their outcomes to particular groups so that it serves a social good. We talked about model risk management. I'm not going to talk a lot more, but it's a very deep subject. And I do believe that we should be deploying those in more situations across all industries versus just the financial services industry. The methods for removing the bias in your models, I talked real quickly about how you do that. There are hundreds of papers and very good researchers and data scientists and practitioners that are working on methods to do this, right? You've got to look at your data, you've got to look at your algorithms, you've got to look at the situation, the technology that you have. There's a process flow in building a model. They're looking at every little step of where fairness and bias creeps in, but I'll leave that for another day. Of course, the specific cultural implications and social expectations, we didn't talk a lot about those, but as you think about the different religions, as you think about the different ethnicities, as you think about different age groups, there's a lot of different cultural implications. The Eastern philosophy and moral codes versus the Western moral decisions and basis. I talk in the end when I'm talking about bias and fairness in different presentations, I talk a lot about how that links to utilitarianism and philosophy discussions that I haven't had since I was an undergraduate. But as you think about the fairness, a lot of this comes back to the value system of the society that it's in. I'm not going to talk a lot about that and all the differences in that around the world, but the moral basis is a lot of the conditioning for this. Okay, so I'm going to come back to the beginning, right, and say bias is not the same as fairness. Hopefully I have convinced you of that, right? Bias, in my view, is a mathematical term that can be defined very rigorously by our mathematicians and our model developers, and you can say with no uncertainty, this is as fair as I can get it or as unbiased as I can get it, and then that works great. But it's not the same as fairness. Again, fairness is a societal concept. It really depends upon the views of the stakeholders. There's a lot of different use cases that I didn't talk about that are out there. But I also wanted to say, as system thinkers, right, that's really required for us to really operate in this world, thinking about how the system interacts and works and what happens when you put a model into a system, how that system reacts, where you're measuring your key variables is one of those critical things. Okay, so I've gone about 41 minutes. I'm going to say here's some references, and there's a bunch of links in here. So we will post this. Naomi will post this afterwards so that you can see some of these. There's actually hundreds more. There's some very good research going on at MIT into the fairness process and the bias process. But here's some of the things I actually talked about today. And with that, I'm going to say thank you. If you want to get a hold of me afterwards, here's the email addresses that you can get a hold of me. And Naomi, I'll stop and say thank you very much and take questions.
Absolutely. Thank you so much for that lecture. I think it was really fascinating. Again, to our viewers, you are welcome to enter questions into the chat window on YouTube. While we wait for some of those to come in, I just wanted to say one thing that I found really interesting in this talk was kind of looking at the system that one would have when creating these models and adding in more information. One thing that we go over a lot in the SDM core class is figuring out who your stakeholders are. And I think it has probably been quite easy for the data scientists, the very tech-oriented people to create models and think of their stakeholders really as the people inside their organization without thinking about all of the stakeholders as the users, for instance, in the financial system, all of the people who would be applying for credit and the various ways in which they may or may not have access, the ways in which they may have faced barriers in the past. So I think it's definitely important to frame it in that way.
Yes, that's one of those things that as I went through the SDM, understanding the stakeholders and who it is and taking the holistic viewpoint is one of those things that you have to learn. And you're right, a lot of the modelers are so worried about the data and what data they have, and did I make the perfect model, that they haven't necessarily stepped back and looked at the holistic view of all the people that will be using it and the people that are impacted by the model. And that's a very, very good point, Naomi. The fact that you're looking at the stakeholders, and that's really the difference as I think about it, is the modelers look at bias and optimizing and working very hard to do that. Where you're deploying in the system, you really need to think about fairness. And that's one of those key things at the point where bias is not equal to fairness, and having that thought process and that perspective is critically important.
Definitely. So we had one question come in from possibly a classmate of yours, Sylvie Bachschorn, who asks, we always had models. What makes them now AI models?
Thanks, Sylvie, and good to hear your name. Yeah, Sylvie and I were SDM 99 together, so always great to hear from one of your former cohort. So yeah, the AI models, and this is actually very interesting to think about. The term artificial intelligence, the term machine learning, and the statistician will, and the financial services people will say, I've been doing that forever. One of the things that at least my own personal definition, and people can discuss this and we can have a long argument like we used to talk about this definition of a system. For me, artificial intelligence is starting to tie itself more to the deep learning and the neural network based type of applications. Machine learning is more of the clustering and other things. So which Venn diagram do you build? But you're right, we've had models. All the concepts that I talked about today really apply to all models. It's not just artificial intelligence. If you think of artificial intelligence as deep learning and different types of neural networks, it does include all the machine learning ones, and it includes just basic linear regression. You need to think through all of that. That's why I kind of use the words interchangeably today: data science, artificial intelligence, machine learning, and modeling. We'd have to have a beverage and a table and be at the thirsty ear or the muddy river to really go in deep on that. But you're right, modeling has been around for a long time. What's happening is modeling is now becoming ubiquitous. It's everywhere. It's every app on your phone, every time you look at a stoplight and it's going on or turning off, and in your car, everywhere there's so much of modeling now that it's so ubiquitous that it's becoming much more important.
A very thorough answer. I personally appreciate it. While we wait for some more questions to come in, Sylvie says, thank you, Doug, that helps. Another thing that I found interesting was when you were talking about optimizing fairness and discussing transparency, you spoke very briefly about the disclosure of models and how they work. And I'm curious about how you personally feel about how to discuss those models, how to discuss what's going on as far as, using legalese. And now that you're in kind of more of the academic world where people also often have difficulty communicating their thoughts clearly and concisely, if you have thoughts on approaches to that.
Yeah, the how you disclose transparency is not an easy thing to discuss. From a corporate perspective, we typically didn't even talk about our models publicly, right? We may have acknowledged that there is a model there, but that's it. We didn't talk about how accurate it was, how biased or unbiased it is. If you disclose that you're biased, then you're immediately going to get sued, right? So how and when do you do that? It's a very tricky and very difficult decision to make in how you do that. The issue is if you don't disclose anything and then you do have a biased model, then it's going to be found out eventually and people will make headline news. So you have reputational risk in there if you're not talking about your model. So one of the things that I think actually works well is corporate people actually interacting with academia and talking about bias and fairness in the academic environment, which is generally a little bit more safe, although some people may disagree with me on that. And working through that. Are you going to discuss a particular model? Probably not, but we talk about models in general and how you're adapting to it and how you're convincing the public that it's actually you're actually balancing their viewpoints inside. And when you get asked, this is where explainability comes in. When you get asked, why did you make this decision in this way? You actually have an answer. You know, that is one of those things. The explainable AI is actually a technique that's coming along now that actually is important, so that when you get asked, why did I get declined, or why did you make this decision, you can actually say, I made it for the following reasons. This is the data I had, and doing that, and disclosing the data. The regulators are starting to get more aggressive, or more specific, maybe I should say, versus aggressive, about how they want you to be able to disclose and what you have to be able to disclose. So it's not an easy topic. I think the academic corporate interactions is one of those areas that would be good to discuss in further detail. But it is not easy, right? And how biased a model is, your lawyers are going to say, don't disclose your biases, even if it's you've done everything you can to make it as good as possible. So they're tough cases, and actually that's where those Princeton case studies that I referenced help you think through, you know, different situations that you know, are not easy and different. And actually, it's interesting, as I taught case studies in classes, different cultures have different viewpoints. And as you're thinking about, you know, deploying things and getting out in the business, it's important to, if you're a startup in particular, I'm going to deploy it, and then we'll see, and we'll fix what breaks, and we'll go, and we'll continue to adapt, and that's one method of doing it. Another is to be very conscious, and those large corporations tend to look at things in more detail. Smaller corporations need to get out and get busy and break things and you know, work through. But that's really two different cultural and moral bases for their decisions.
Definitely worthy of its own entire lecture, honestly.
Yes.
We had another question come in from Tom Courtney, who asks, should ethics in AI become an SDM topic? And I'm curious also how you feel, or how the School of Data Science at UNC Charlotte is handling ethics in AI.
Yeah, well, I'll answer the second one first. So the School of Data Science at UNC Charlotte, we are actually integrating the ethical decisions in the development of our courses. There's really two choices schools are making. Do I have an ethics class? Right, so I can take a 3-hour credit course and say this is AI ethics, and we can have a faculty member teach AI ethics as you're doing it. That's one choice. Or you can actually take it and integrate it into your curriculum. You know, pedagogically, very different decisions. We've chosen what I think is actually the harder path, is to integrate it into our core course development. So we actually have a professor of philosophy that specializes in data ethics, that's sitting with our computing and our faculty to make sure that the ethical implications of the class projects and the discussions are actually built in. So even in the freshman level courses, we're actually giving data that's actually biased, so that the student, as they're working through, and then you say, hey, did you check for, you know, ethnicity, and did you get different results in your modeling? They're like, oh, they're actually different. So they're trying to learn and understand how bias and then the concepts of fairness come in. We're also teaching a lot of our data science in the concept of a social science, so sociology, political science, you know, criminal justice, and using these examples that are in the literature and we are debating as a community in the classroom, so that they can actually bring it closer to what they are observing every day. Now, I'll switch to, should it be taught in SDM? SDM, the curriculum was migrating when we were there, ever evolving as it should. Depends on how much artificial intelligence you're teaching. I think it would be a great topic. Obviously, I'm a biased person about artificial intelligence and doing it. Should at least, you know, be an option for system thinkers? Absolutely. Maybe as an elective or a special topics class would be great. But system design and management covers a very broad area, and it's always difficult to say this specific topic, if it's not actually core that everyone should be taught, you know, be there. But having an elective, probably a good idea.
Yes, it is definitely a very broad curriculum, and the core has changed drastically from when you were a student. We now have a single integrated core class that runs for the entire school year. Um,
Uh,
and then students do actually have the freedom to take electives across the Sloan School of Management and the entire School of Engineering. I don't actually know how that's going to interact with the newly announced School of Computing. I
yeah,
know that this is only from a layperson's perspective. I'm not part of the administration for them, but I know that ethics has been a very hot topic in the creation of the curriculum there, in
yep,
the staffing of the professors who are going to work there, and the faculty as well. So it would not surprise me if that became more of a significant subject within SDM. And certainly the students who come to SDM come with varying interests of their own. When we have more people coming in who are interested in computer science and in AI, more of them do often have the opportunity or the interest in studying topics like ethics and fairness.
yep. No,
So
and the
it's a really
Schwarzman
good point.
School, right? The Schwarzman School of Computing is going to be a leader in this, right? It is one of those places where we will look to and see what they're doing and adopt practices, and hopefully, as we're leading through integrating this into our curriculum, hopefully we can share that with the world, and people can pick and choose what they use. The Schwarzman School is fantastic, right? I wish I had $1 billion to use to build a new school, but unfortunately here at UNC Charlotte, we don't quite have that much.
Yes, I think it's going to be really interesting how that school evolves as part of MIT and as part of the structure of the university, and how our students are able to interact with it, since currently computer science is part of the School of Engineering. So we'll see how it goes. I honestly do not have enough information to say at this point.
Yeah, we are all academic worlds, and data science are evolving. We've chosen to have a school of data science that actually sits in 4 colleges. MIT is doing it slightly different. Berkeley's doing it different. UVA has a school of data science. So we're all experimenting and collaborating with each other as to how to best do this for our students and for society.
Absolutely. And I think the only way to deal with it is to continue to be flexible and to adapt.
Absolutely.
Yeah. Doesn't look like we have more questions coming in right now. So
Okay. Well,
if
I'll
you'd
wrap
like, we
up if
can,
that's okay.
yeah,
You want me to wrap up, or are you wrapping up, Naomi?
I think we can wrap up a couple of minutes early. So I will say again, thank you so much, Doug, for joining us today, for sharing your time with us. I hope we can have you back in the future, hopefully on campus. And again, thank you to all of our viewers for joining us. Thank you for attending. The presentation recording will be available online after this session, and we should be able to get the slides and those links to the references up very soon as well. We hope you will join us for the next Systems Thinking webinar in May. And on behalf of the System Design and Management program, thank you for joining us.
Thank you, everyone.